Hello, everyone. Welcome to the GSE UK Conference 2021. This is session 2AQ, and we have Ilya Abnitsky and Vladislav Kolesnikov to talk to you about how to connect Mainframe with Jenkins pipelines using USS. If you've got any questions to ask, can you post them in the chat, and we'll get them answered at the end of the presentation, if that's okay. Okay, over to you guys.
Okay, thank you. So my name is Vladislav, and I'll start this. Today's article is how to connect Mainframe with the Jenkins pipelines using USS. Okay. So why we are here today? Let's consider the situation. You're trying to modernize your mainframe software development group. You know that doing so will increase your speed and efficiency, but you don't know where to start. So you search the web for some way to bring DevOps practices to your mainframe group. You find many different methods. They sound good on paper, but they will fail in practice. And frustrated, you try to create your own tools, integrations, and processes by scratch. But the whole project takes more time and effort than you think. It's worse. And you ultimately give up on the whole idea or bringing DevOps to mainframe. It's a painful cycle, and we are here to help you break with it. So we are going to give you a good functional solution to the problem of how to bring DevOps to mainframe software development. And we will do so in 3 steps. The first is we will discuss the overall topic of how to bring DevOps practices to mainframe software development and tell you the best way to do so. Second is we will provide a concrete example of our approach and to walk you through how to connect a mainframe with Jenkins pipeline using USS. And finally, we will provide some additional tools you can use to bring more DevOps practices to more aspects of mainframe software development. Sorry. Okay. Why you must bring DevOps to mainframe software development? Before we dive into the details, let's take a quick moment to break down why bringing DevOps to mainframe software development matters, and why it's worth putting in a little effort to learn how to combine the disciplines effectively. So at a fundamental level, this is just something that you have to do. Every corner of mainframe has begun to adopt DevOps practices, and sooner or later you and your software development group will face some pressure to modernize as well. So the reason for this is simple. DevOps brings a lot of benefits to all things mainframe, to all mainframe things, especially mainframe software development. In particular, DevOps can dramatically accelerate many of your core processes. For example, traditionally, it has been normal to write several lines of code for a monolithic structure and then wait hours for it to compile. With DevOps practices, you can complete this work in seconds. In addition, with DevOps practices, you can bring in new transformative practices like continuous delivery, continuous integration, or CI/CD as abbreviation, and automate many steps of your work. Those are included as automated builds, automated deployment, testing, code quality verification, monitoring, and CI/CD. So all of this adds up to one big benefit. With DevOps, you can deliver higher quality software more consistently, much faster to your customers. And even if this doesn't matter to you, it certainly matters to your senior stakeholders in the business. and they will pressure you to modernize your software development practice. In some, even the most old school mainframe software engineer will eventually have to find some way to bring DevOps practices to their work. But unfortunately, many mainframe people are following a suboptimal method of doing so. Let's talk about the wrong and right ways to unite DevOps and mainframe. Bringing DevOps and bringing DevOps and mainframe is not always easy. DevOps and mainframe are not always a perfect fit. What's more, DevOps has come to mainframe later than it transformed other corners of IT. This means that DevOps for mainframe is still a few years behind the broader trends, and most of the tools developed for this market are less than perfect. Because of this, many mainframe software development teams are following the wrong way to bring DevOps practices to their work. They are looking at the market, they're seeing that DevOps for mainframe tools won't work for them, and they are choosing to create their own homegrown tools from scratch. This is understandable, as teams believe that DevOps tools they build for themselves will be faster and more reliable than anything on the market. And in some ways, they are correct due to the current immaturity of most tools on this market. However, we have come to see that this approach is often fundamentally flawed for one big reason. Most teams do not create reusable internal DevOps solutions that they can apply again and again to solve a wide range of problems. Instead, most teams build a single-use tool that can only solve the exact immediate here and now problem that they are struggling with. As a result, most teams burn through a lot of time, labor, and budget developing products that only work under specific conditions and which must be thrown away as soon as those conditions change. Now, like I said, this is an understandable approach and it's not anyone's fault, but thankfully there's a simple solution to this problem and a better approach. While there are not a lot of great DevOps for mainframe tools on the market, there are tons of great general purpose DevOps tools on the market. And even though these great general purpose DevOps tools were not designed especially for mainframe, most of them can still be adapted for use within mainframe environments. Ultimately, we have found that this is the best approach to bring DevOps practices to mainframe. Overall, it is much faster, simpler, and more effective to just adapt existing general purpose DevOps tools to work within a mainframe environment than it is to try and reinvent these tools and create new approaches from scratch. While everyone has their own unique mainframe with its own unique challenges to overcome, we will show you that you don't need a unique solution to do so. We will show you how a general purpose tool like Jenkins can solve most of your problems and automate many of your manual mainframe processes. Fast, simple, and easy. So, meet the Jenkins general purpose DevOps tool that works great with mainframe. Jenkins is an existing general purpose DevOps tool. In simple terms, it is an open source automation that makes it easy to automate many tasks related to developing, testing, and deploying software. Jenkins brings a lot of benefits to mainframe software development, especially compared to creating a homegrown solution. So why should you use Jenkins instead of homegrown solution? It has already solved many automation problems and can automate many tasks for almost any solution, regardless of the scope of the solution's infrastructure. It was developed to coordinate software building, testing, and deployment processes across multiple platforms. It has a huge number of plugins and integrations extending its reach. It uses Groovy scripting-based pipelines. It uses REST API to allow information feedback and pipeline triggering. It offers most of these capabilities out of the box. And most important, Jenkins is an active open source project. It has a large and engaged community. It already has a lot of documentation, examples, and support. And the tool is well maintained and constantly expanding to tackle new automation challenges. Jenkins makes it fast, simple, and easy to bring a lot of DevOps practices to mainframe software development. It's a great example of how you can save yourself a lot of time, effort, and budget by using a general purpose DevOps tool instead of a homegrown solution. And it's worth finding a way to bring it to mainframe environments. So how to do that? How to bring Jenkins to mainframe? And we'll start from the imperfect options. So far, the world of mainframe hasn't produced a definitive answer on how to best connect Jenkins to mainframe environments. Instead, most teams are using one of three imperfect options. And the worst method is to run Jenkins directly on mainframe. It wasn't built to be mainframe native, and it doesn't run very well when it's run directly on a mainframe. Specifically, it requires a lot of very expensive CPU time. Other external services need to be available at the same time as Jenkins, and you must find somewhere to keep them. And you need to open additional access for external services, which is costly and unreasonably difficult, and creates additional security challenges. Due to these challenges, among others, teams shouldn't run Jenkins on the mainframe itself. Instead, they should keep Jenkins an external service that they run on a separate server. Of course, running Jenkins as an external service creates a new challenge, how to make contact between Jenkins and the mainframe. Other methods attempt to provide a solution to this challenge. The first option the first option is to use IBM's EOS plugin for Jenkins. As a whole, this plugin is a good solution to connect Jenkins and mainframe. It provides rich functionality to automate some processes, and it provides the ability to perform some mainframe-specific actions, like running just jobs and so on. However, this plugin has some limitations. It only allows you to use Jenkins to interact with the mainframe CLM. While this makes it a good solution, if you are still storing a CLM on the mainframe, most modern teams have abandoned the CLM and now work through GitHub, Bitbucket, and some other VCS. It makes this plugin obsolete for many teams, unfortunately. So the second option is to build custom solutions. Some teams choose to build a homegrown solution to connect Jenkins with the mainframe, either by cobbling together third-party applications or by creating something from scratch. While creating a custom solution will give teams some very good experience developing solutions, it is not an easy path, and it is totally unnecessary. Overall, while both of these methods have been useful, they are just too complicated, too time intensive, and too high effort to be used at scale. Mainframe software development teams need a modern and proven solution to connect Jenkins with mainframe. So there is a simple way to connect Jenkins and mainframe. To be clear, in the past, we've made every possible mistake as we tried to connect Jenkins and mainframe. We initially created a custom solution with a lot of homegrown adapters and connectors, and our solution worked well enough, but eventually we realized that there was a much simpler way to connect the two systems. One day we read carefully through Jenkins documentation. We learned that Jenkins already had some useful tools in its existing implementation methods. We realized that we could use those tools to connect Jenkins to Mainframe in just a couple of steps and without developing any plugins, simply by using the existing Jenkins agent. The Jenkins agent is just a Java program that runs under USS. The Jenkins controller is the original node in the installation, and the controller administers the Jenkins agent. And orchestrates its working, including scheduling jobs on the agent and monitoring them. This agent can be connected to the Jenkins controller using either local or cloud computers. All it needs is a Java installation and a network connection to the Jenkins controller, and it provides a simple way to connect Jenkins and Mainframe. Once we learned how to use the Jenkins agent, we looked back and at plugins or custom solutions. This agent gave us a simple, straightforward approach that delivered many benefits. Specifically, we learned that this agent is self-sufficient, first of all. So you don't need to install any additional tools on the mainframe except the Java program to make everything work. By Java program, I mean the Java SDK for mainframe. Lightweight and simple. This solution won't take up too much disk space, and it will not overload the processor with a lot of work. It is not loaded with business logic. It is just a simple automation tool which allows you to implement it and abandon it very quickly and easily. And also it is a secure solution. With this agent, you are implementing automation into the mainframe with minimal external dependencies and a small impact on security. Of course, the Jenkins agent is not perfect, and it does have some limitations. You won't be able to perform certain tasks on the mainframe other than basic access to it, and it requires Java on USS, but it is no problem to put Java on USS, I think, and the problem of implementing most serious tasks has long been solved by other external components. Ultimately, the limitations of this approach are much, much smaller than the benefits you will gain by using agents to connect Jenkins to your so I think the next things with the details will be discussed by my colleague. Ilya, please go on.
Yeah, thank you, Vlad. So let me introduce myself. My name is Ilya Abnitsky. I also working with Vladislav in the ABA group as a DevOps engineer. So I hope you could hear me now. And I should share my screen. Okay, screen share. So I hope you could see my screen now. Talking about how we could connect Jenkins agent to the mainframe. So thankfully, you only need to solve a few problems. Just 1 second. Okay. Thankfully, you only need to solve a few problems to use the Jenkins agent to connect to the mainframe environment. Specifically, you need to just have Java pre-installed on the USS part, open access so the agent and Java can interact between each other, configure your initial settings in Jenkins, and manage the agent through the Jenkins. So most of these challenges, most other challenges that you might encounter already have a simple solution developed. So you can find this solution and more by reading through Jenkins' existing documentation on the internet with the official Jenkins documentation. So to get you started even faster and easier, we have prepared for you a small demo showcase with approach that our team uses currently. Our team has followed this approach to connect Jenkins with Mainframe on the real project for at least 2 years, I remember. So we all know perfectly well how often something that has always worked start to break on live demos. So I decided to pre-record a short video with our showcase, so as not to waste your time. So here I should start it. And also 1 minute. Okay, screen sharing with sound. And I hope you could hear the sound from video. And here we go. So to begin with, we should start with the Jenkins environment preparation. First, we need to create, for example, the new instance of the Jenkins agent on the mainframe and deploy it on the USS part. So to do this, we need to open Nodes tab in Jenkins and click to create new node. So, and also on this tab, as you can see here, we have a list of currently running and available Jenkins agents. Some of them are currently running on the other Linux machines, and some of them running on the mainframe. So as you can see here in the architecture, you can see that ZOS. So click new node. For example, choose just to demo test node, permanent agent. Okay. So here on this tab, you should configure all configuration of your node. So description tab is just description about your node. One of the important fields in this tab, it's like number of executors. My suggestion to you, choose minimum 2 or better 3 executors. That means that in one moment, our Jenkins agent on the mainframe could run 3 processes in parallel. So it's better for multitask and performance. So we choose 3 executors on the mainframe. Remote root directory. So here you need to choose in which directory and by which user Jenkins agent will be placed. So in our case, just user Jenkins workspace. So here under the workspace directory, Jenkins agent will be deployed, will be running, and all his stuff will be placed there, such as agent sources, sources of the jobs pipelines, previous executions, all downloaded sources, and so on, and other stuff. So this is a place where all magic is working. Another field, such as labels, here you could choose test node as your name of your Jenkins agent. It's needed in future by this label. In pipeline, you will specify on which mainframe or another agent some actions will be performed. For example, you type in your pipeline code that in first stage, you need to execute some shell scripts or some steps and stuff, run on the test node via specifying this label. So the Jenkins understand on which mainframe agent you will run your actions. So after that, usage is only built jobs with label expressions matching this node, and another important field, launch method. So currently, I'm describe you the first way how we could connect mainframe agent to the Jenkins server. I mean that the first way is by using GNLP connection. It means that connection will be started from the USS side after complete this test node configuration. Will be generated Java command which should be copied and executed on the USS side. So it means that we initiate connection from the mainframe to the Jenkins server, from the mainframe to the Jenkins server. So for this way, we only need to open port like 50,000. So for this solution, if you have some strong firewall rules or some gateways which do not allow you to connect your mainframe with Jenkins via 21st port, like via SSH, so this is only way how you could connect your Jenkins agent to the Jenkins server, only just by using GNLP. For doing this, you need to choose another launch method like launch agent by connecting it to the master. So connection will be initiated from the USS. So after that, in advance also you need to place file encoding for JVM like this. Availability keeps this agent online as much as possible. And that's it. Click save. And here we could find that agent was created just only on the Jenkins server. And here you can find required command, as I mentioned before, which should be run on the USS part, like here from the command line. So by executing this command with also automatically generated secret token, Jenkins agent will be launched on your USS side and automatically connects to the Jenkins server. But as a limitation of this solution, the first way how we could connect our agent is that if your Jenkins server somehow restarts or some troubles were occurred, so after restarting Jenkins, your agent will be disconnected from Jenkins server, and after that, it should be needed to restart again by hands from the mainframe from the USS side. So the one of the workaround is create some automatic just maybe any shell script or reg script which automatically restart your for example this command on the USS side when previous execution of this command process will fail. So this means that we don't need any manual action will be performed on the USS side. So it's about the first way how we could connect Jenkins agent, and the second solution is the best solution. For example, is by connect your Jenkins agent via SSH. So you need to open 21st port for SSH connection, and for example, which are currently running via the second solution by SSH connection. Here you also could find all the same stuff, but launch method is another. Launch agents via SSH, where you placed your mainframe address, credentials by which you could connect your agent to the Jenkins server. This means that you need to generate SSH key pair with public and private key on the USS side and place them in the credentials field. Host key verification strategy is the same, and host style the same as before. So why this solution is better than previous one? It's because we could initiate connection to the mainframe just only by Jenkins. And Jenkins is a clever guy. So when your Jenkins somehow restarting or some troubles were occurred, Jenkins will automatically from Jenkins server initiate connection from Jenkins server to the mainframe. So we don't need any custom scripts for restarting Jenkins agent from the mainframe. So Jenkins by itself will restart and initiate a new connection to the mainframe, and that's it in automatic way. So that's it. This is the two ways how we could connect Jenkins agent. And here, just for demo purposes, for example, I will execute one of our development pipelines by which we used in our development to see how its magic works. So, for example, here on the USS, I want to show you that let's see, the Jenkins. So we choose Jenkins user, cd user Jenkins. And here you could see that we have workspace directory, as I mentioned before. Okay, sorry, mistake. And another workspace directory. And here we go. As you can see, here we have environment management directory, the same as our pipeline environment management, where all sources of execution of such pipeline placed on the USS side. So we choose this one. And what we see, oh, sorry, caps lock. And here, as you can see, we don't have directories such as env3, just only env2. So by now, I will show you how it will be generated by Jenkins, which will create a new instance of environment 3 with all needed sources, where we copy some sources of our Java program to the USS part in the such environment env3 directory, and we execute it on the USS side. So here for my evidence that we don't have any currently running processes. So as you can see, grep env3, currently no program with env3 running. And here we go. I'm starting the pipeline. Start environment. So also in Jenkins, for better like user experience, you could also install Blue Ocean extensions for your Jenkins. It's like this. And so it looks much more better than than the old Jenkins interface, like in the modern way, but also with the same functionality as standard Jenkins interface. So you choose on which screen you could perform some actions. So here we need to configure our environment to start. So I choose N3, choose my desired images, and proceed. So here we go, our pipeline currently running. So and here you can find and here we go, our pipeline currently executing. Also, and so here we go. This is the one of the stage which interact with our Jenkins agent on the mainframe side. So I choose select which of the mainframe I need to choose, where my Java program will be launched, on which Jenkins agent on the mainframe. So for this example, proceed. And here you can see that our environment3 directory now created. So let's get in. And here you can see that we successfully transferred our program sources, our Java program sources, and which program we need to execute on the mainframe side. And again, as I mentioned before, by executing such command, we execute it again. Okay, still in running process, so we need to wait some actions. Okay, forget and forgot about it. So and by another try, here it is. Our Java program was successfully transferred to the mainframe, to the USS side, and successfully executed. So as you can see here, it was made by Jenkins from the Jenkins server. So I think that's it. So here we go. I really apologize for the large amount of blurred text and areas during this video, and I hope you could hear me now. But during this video, some of the data was confidential, so it needed to be hidden. So, and by by implementing such solution, you can integrate mainframes with a wide range of modern tools, which also could be an open source tools, of course, and services thanks to Jenkins. So transfer work on the mainframe to the convenient Jenkins web interface, control from there on which mainframe, what and how will be deployed and executed, and control the process from the web interface. So this allows you to implement wide automation and automating testing and, for example, such quality gates, for example, SonarQube and many other useful tools and services. As an example, for the one of the simple workflow approach, like you or other developer make some changes in your code in his IDE. So after this, he makes some commits to the GitHub or any other source code management system, for example, Bitbucket, GitLab, and so on. And after that, when push or commit arrived in your source code control management system, you there will be pre-configured webhook, which will trigger Jenkins by whatever you want actions in your for example GitHub. So your GitHub webhook will trigger Jenkins build, and pipeline will start it including the Jenkins agent. So this will grab everything from the GitHub commit, performs the automation, and sends everything to the end users. So going beyond Jenkins, additional general purpose DevOps tools for mainframe. If you liked our vision of how we implemented this approach, you can easily try doing something similar that will help you maybe somehow to automate your workflow and help you to avoid some custom unnecessary solutions. I would also like to add that this way of integration between Jenkins and the mainframe somehow allowed us to achieve great scalability on our project. For example, we can easily connect everything together in one automated pipeline. Seemingly distant things like, for example, containerization using principle of infrastructure as a code, integration our processes with Jira, Slack, SonarQube, Docker, and other modern tools and services. At the same time, so you will learn firsthand that the easiest and most reliable way to introduce DevOps practices to your mainframe is to simply identify an existing and proven general purpose DevOps tools and find a way to use it in your environment. With that in mind, we recommend you take some time to get familiar with a wide range of open source general purpose DevOps tools that have already been used extensively in the real world and proven their ability to solve automation issues. So here are a few more of our favorite general purpose DevOps approaches that you also can adopt for the mainframe. First of all, of this solution is shell scripting. So this method retains a lot of manual settings and is good if you only want to automate a few steps of your DevOps process or automate some manual stuff. You have some kind of automation base and you don't want to redo everything again. So another solution is to use Azure DevOps for Mainframe. We have used this technology in our another local project like DevOps as servers for the Mainframe project. The principle of operation is extremely similar to Jenkins, especially Jenkins pipelines are written in the scripting language such as YAML. Yet another markup language. And if you have used many shell scripts, for example, in Jenkins pipelines, and want to transfer them to Azure pipelines, then this will be easy to do, since the principle of writing pipelines in both tools is very similar and simple. So, and the scripts will do the main work. So, and the last one, UCD, such as IBM Urban Code Deploy. This is CI/CD tool from IBM that is primarily used to create pipelines for code deployment. And the working principle is also quite similar to Jenkins and Azure DevOps, also with help of some Groovy scripts and so on. So if you would like some hands-on help using Jenkins in your mainframe software development environment, or some personalized advice on which open source general purpose DevOps tools you should bring to your mainframe group. So if you got any questions, you could contact us anytime, and thank for your time. I hope the session was quite useful for you. So I think that's all I wanted to share with you.
Yeah, thank you. And you guys, if you have any questions, then feel free to ask us.
Any questions, anybody? Okay, thank you, guys. That was very interesting.
Yeah, thank you all.
Yeah, thank you for presenting.
Yeah, thanks.
Okay, yeah, good talk, guys. Thanks for that. Yes, that's one thing on the chat. So
yeah, see. Yeah, thank you, Thomas.
Okay, bye.
Yeah, bye for now.
Yeah, take care. Goodbye.